Hello again. I'm Jim Lindeman. Last time we talked about fossils, and it was kind of fun because some of the things that are out there and some of the things that kind of shake up the evolution type of concepts was really good to take a look at and see that maybe it isn't all the way we think. Now comes perhaps even a little, what you might say, a little bit more serious. And that is, how does evolution date things? And to be aware of the fact that there are certain assumptions and certain things that go into what seems to be very clear, concise dates. So we're going to do a little bit more about that. So we have current memos, recent memos, ancient memos, Mesozoic memos, and coal. Some are at the bottom of your desk. Old memos are being pressed into coal. No, ma'am, I don't know what happened in 1540. No, ma'am, I don't know what happened in 1680, 1820, or 1910. However, I might be able to make a wild guess at what happened right after breakfast this morning. And her little peppermint patty friend, no, that's peppermint. Anyway, her little friend says, "You're weird, sir." Okay. A prehistoric man mystery. Discovery. In the valley called Neander, in the mountainous region, there was a very important historical find today. During construction, ancient bones were accidentally unearthed. They were declared to be the bones of a prehistoric type of man who lived over 60,000 years ago. Okay, the valley called Neander. Neander was the man who wrote a number of hymns. Praise to the Lord, the Almighty, the King of creation. O my soul, praise Him, for He is thy strength and salvation. Come ye who hear, brothers and sisters draw near. Praise Him in glad adoration. It is in His valley, and it's kind of an irony that there you have evolution, which is basically trying to remove God, and in His valley, this is what he used to sing, what he wrote. This is the way he approached life, was that sense of the praise of God. He wrote others as well. So it is Neanderthal. Thal means valley, or tall means valley. Thus begins the first newspaper account of the discovery that has been come to be called the Neanderthal man. The story ran in September 9, 1856, in the German newspaper Barmer Bürgerblatt. Okay, note the date of the discovery, 1856. On that day, Neanderthal was assigned a 60,000 year old, the bones were assigned at 60,000 years old. So the age of the bone is stated, the date of discovery. What went into the ability to date those bones at 60,000 years? Okay, the puzzle. A prehistoric type of man lived over 60,000 years ago, September 9, 1856. 1856 is 42 years before Marie and Pierre Curie discovered radium, which ushered in the radioactive age. So it is 60 plus years before radiometric dating. Even so, there are some problems with such dating. So in other words, they didn't have tools to be able to come to the conclusion of 60,000 years. How did they get that date? Where did it come from? 1856 is 10 years before Gregor Mendel published a significant work on heredity. Even then it was not really accepted until 1900. So there was no essential exploration into genes. There was no concept of how heredity gets passed on. There was no idea of rates of mutations to be estimated by observations not yet done. So how do you know it took 60,000 years? Whether the rock is on top or bottom is meaningless. Would not the bottom be deposited first, therefore is older? Well, you take a look at Chief Mountain, which is right down the road from us. Its top rock is Algonquian, which is about 2 billion years old or so old. Its base is Cretaceous, only 200 million years old. So how did this older rock, by 2.8 billion years, get on top of younger rock? The thing about it is, if you go down there, you will find that what's called the horizon between these two layers is like paper thin. So somehow that older rock got on top of the younger rock without any kind of scraping, without any kind of churl or churning up of the stone surface. How do you get a paper thin horizon between this kind of a situation? So something's going on here in which it doesn't matter what the rock is, it gets assigned certain ages. It doesn't matter that you don't have any of the sources of being able to say, okay, this gives us a better idea as to length of time. You don't have any of that. So what gave Neanderthal man, that first one, the age of 60,000 years, and basically not been challenged since? The basic date framework was firmly in place by the early 1800s. This was 3 years before Darwin published On the Origin of the Species. So you can't necessarily say that he is even responsible for these dates. So, how do you get them? Science is observe, test, repeat. But you can't. How can you do that? Chief Mountain is Rocky Mountain overthrust, paper thin horizon, no slick inside, breccias, gouge, weathering, that's shown between the two layers. Your test is prediction. Well, how do you predict how that can happen? What's the dynamic? What's the mechanics? Where does the energy come from to be able to so cleanly move a huge span of stone without any evidence of it being moved? Assumptions. In an MIT seminar, a story was told about an engineer, an architect, and an economist, the only survivors of a plane crash in a lonely island. In a week, the only food left was a can of beans, and they didn't even have a can opener. Start a fire and put the can in the middle, said the engineer. The heat will cause the can to burst. The architect shook his head. Unless we build an enclosure, the beans will fly all over the island and we won't have anything to eat, he said. At a loss about what to do, the engineer and the architect turned to the economist and said what idea he had. Assume a can opener, said the economist. When it comes to dating, that's the problem. What do you start with as the assumption? Assumptions from which you now build your case do not make reality. The reality has to be there before those assumptions begin. Why must we assume the long ages? Because this is the only solution that's given to us. You know, how long ago did the dinosaurs live? Hopefully last week we kind of shook up that thought. But how do we know that they lived 65 million years ago? Well, that's what everybody tells us. So now we have to go to the Bible. We have to conform the Bible to these long ages. And what we're doing right here so far is challenging how do you get those long ages? And basically they were made on assumptions. First of all, the assumption that God can't know what he's talking about because there isn't any God to worry about. And therefore now how do we figure out how you could have what we have now in this world by itself? And there's the idea, the assumption is that time solves all problems. Time will give us whatever we want. Give us long enough and you can change the world. Give us long enough and you can change species into other species. And therefore, the assumptions create the problem of how can this happen? Okay, we're going to take a look at wherever it is. There you go. Radiometric dating, radioactive dating problems. All right, this gets complicated if you're not familiar with it. And so hopefully I can get across clearly what we're talking about. The idea of radiometric dating is that you have a certain quantity of a radioactive isotope, radium-236, radium-238, or whatever it may be. For the length of time it takes for half of it to decay is called a half-life. And the thing is that supposedly, at least, it takes the same amount of time for that to go half. And it takes the same amount of time for this much to go to half, and so forth. And so if we can get some kind of an idea as to how many half-lives have occurred, and if we know the half-life span, we have a pretty good idea of the age of the thing that we are dealing with. So of a given amount of radioactive material, the time it takes for half the material to decay is called the half-life. Assuming the rate of decay is accurate and constant, 1/4 of the material means, in other words, if you're down to here, 2 half-life periods have passed. To measure half-lives that have passed, the original amount must be known in order to compare it with its daughter products. So in other words, you start out with uranium-238 and you have, I think it's about 18 steps before it ends up with lead 216 or 218. So in other words, if I collect all these daughter elements and then I put it against the uranium-238 or uranium-236 or whatever it may be, if I take the daughter elements and put it against what is the mother of all these daughter elements, if I put them all together, then I can figure out how many half-lives have occurred, and therefore what the age of a certain item is. Unfortunately, how do you know what the original amount is? As Shakespeare put it, that's the rub. Okay, the cosmic evolution. You start out with the Big Bang, and the first Big Bang comes, after the Big Bang you have the first star being formed, which gives you common elements, then this explodes, and then you have another star that's formed, and therefore you have the heavier elements. This may have a couple of different steps like this. That explodes, and now you've got all this elements going in transit to end up with the Earth, to end up with the sun that we have, and so forth. That this is the idea of cosmic evolution. Now, the question is, can a star specialize in only one element and not the daughters? So in other words, say for instance with the heavy elements, and you have, say for instance, uranium-238, what about all the daughter elements? Would not they also be formed during the same time the radium-238 is? How do you know what that proportion is? And then in transit, so you have radioactive. Is there decay in transit? If this is taking how many millions of years or more for this to finally come to this point, how do you know that as you start out with a certain proportion and you have radioactive decay en route, that would also change what that percentage is. And then you get to the Earth. Well, how do we know that everything is evenly distributed? How do we know that there's not some sort of sorting that went on, or leaching? In other words, we know that, like for instance, lead can leach out. One of the steps, or one of the daughter elements, is argon, which is a gas. And we know that some of these things leach out because we have problems with people's basements getting filled with radioactive gas. And there are some places, especially where there's clay, that there is big warning about this kind of a buildup in the basement. So where is this coming from? This is coming from the decay of uranium. So we know that even while it's sitting there, you won't be able to check or measure all the daughter elements because they may not be there to be able to be measured. The capture of free neutrons. Sometimes you have that, and that can happen in the ground and throw off what you think is a daughter element, or what you think is a lack of daughter element. In other words, you must know the parent and the daughters. But you don't know, well, how much was the parent there? And you don't know how much is really left that is the daughters of what was there in the beginning. So in other words, as you take a look at how, say, uranium-238, how do you know for sure what the starting amount was? How do you know for sure that some of the daughters that you're seeing are not from the decay of uranium-238 in that rock, but may have occurred at other times? How do you know that? How can you be sure that what you start out is exactly what you think it is, and that what you end up with, again, if you have leaching or you have anything else like that, that's really the amount? Or are these going to throw off your calculations? You have the question of how long does it take for a half-life to occur? First of all, you have for uranium itself, you have a half-life of 6.4 billion years. That's the age of the Earth. And so in 100 years, you are going to test the half-life of something that's 6.4 billion years. And we'll talk a little bit more about the problem with that. Also, can you guarantee in all of that time that the rate of decay is constant? And more now, you have evidence that there are other things that do influence rate of decay. One of the big problems about decay is we don't know what triggers it. And therefore, that's one of the problems of being able to identify how could this be constant? Is it happening? Or were the triggers not there? Or were the triggers in abundance? So that this rate of change occurred very much rapidly, so that by the time the Earth came, you have so much of the daughter elements that now you have thoroughly thrown off any idea of how much that stone started of the original, say for instance, uranium-238, because not all the daughter elements came from decay while that rock existed. What triggers decay is the rate of decay really constant, and we don't know whether there was something that was added in or something that leaked out, like I said with argon. And the fact that that a lot of the substances can be leached. So we have a lot of problems in regard to radiometric dating because there is so much we don't know. We don't know how much, therefore we cannot know how much has decayed while that rock existed. So here you got uranium-238 to lead-206, which is stable. All the steps. We know that radon gas is what goes into your, which is what ends up in people's basements. You have all kinds of other things that lead, and this lead can be leached and leached out. So you have all kinds of things that throw this whole calculation out of whack. Uranium's half-life, supposedly 4.4, allegedly the Earth's age. How can conclusions of accuracy be checked? How can you tell? Knowledge of radioactivity is just over 100 years old. That is 0.000000025% of the half-life. So you're going to take this much zeros in front of 25 and conclude the value of 1. You don't know. Proportion of mother to daughters when Earth is formed is unknown. To assume that no daughter elements are present would require special creation. In other words, if you have the researcher assuming that all the daughter elements are from the mother, and that was what the original started with, was just uranium-238 or whatever, that it was just that, and there was no daughter elements in there, there is no possible way, as we take a look at the evolution of the universe, what we just in a slide previous, there's no way that that's going to happen. The only way that you're going to have that pure a piece of rock with just uranium-238 and no daughter elements, that would require special creation. That would require God stepping in and saying, I'm just going to do this. But if you're going to hold to evolution, there is no way you can end up having any idea of what daughter elements were there prior, what daughter elements came in after, what daughter elements leached out. You have no way of knowing. And so therefore, when you have dating based upon assumptions that just aren't true, by evolution's own standards, you've got a real problem. Okay, which rock is being tested? Now, usually you're not testing dinosaurs for uranium-238. If you are, then you are already admitting that uranium-238 leaches in or leaches out. And so you've just ruined your own basis for measurement. If you're trying to do something like that. And so instead you basically are testing the stone. Sedimentary stone is eroded stone from somewhere else. Sediment from somewhere else could have more than one source. How long did the elsewhere stone exist before it was turned into sand or whatever was the sedimentary stone? How long did the elsewhere stone erosion take place? And so again and again you have this question of how can you come to a conclusion as to the age of, say for instance, this dinosaur bone, when you can't depend upon the decay rate, or the decay, and you can't depend upon the fact that the stone that the item comes from is virgin stone, but rather stone that has eroded and has gone through how many ages before it got to that point. So now you have really very, very bad ability to give an actual age. And like I said, if you test the uranium-238 cascade into its daughters in the bone, then you've already lost your argument. Because how did they get into the bone? They weren't there originally. They had to be leached in by water, and you just have no idea then how much should have been there when you started. And you don't know whether the stone was water sorted. Heavier stone goes to the bottom. Or did it not? Or how do you know the dynamics of the water sorting? Again, the picture. If the bones themselves are tested and the elements are leachable, is the leaching constant for all daughter elements? And so can you have lopsided results because of what can be leached and what may not be able to be leached? You see, when you get into the area of radiometric dating, there are some really, really logical problems in regard to how do you base your judgment. The date scatter problem. This is fun. This is really very interesting to see how the whole process works in our scientific world of radiochronology. The date scatter problem. Radiometric dating can produce a range of dates. Compton and Pigeon in Nature magazine, which is a peer-reviewed journal, which means that this is really the important type of journal that gives you what is really the scientific view. These guys obtained 140 zircon crystals from a single rock unit. This was in Australia, and this is being touted as the world's oldest rock. It was subjected to uranium concordia, and uranium thorium concordia. In other words, they would try to take two and use the information from the two at a time. One crystal showed a UU date of 4.3 billion years. One crystal out of 140 on one of the two tests that they applied showed this age as the age of the stone. One crystal, not all 140, just one. Therefore, the rock was claimed to be the oldest yet discovered. However, the other one, the uranium thorium, showed it as undatable. So altogether, all 140 crystals showed such confusion of information that any other discipline would conclude that there was no reliable, usable data. Yet, all contradictory data was rejected in favor of the single half sample. In other words, they threw out the results of 139 other dates and stuck to only this one. So imagine, if you will, a pharmaceutical company has this really new wonder drug, and they test this on 140 people, and only one person improves during the time of that test, and they can't really tell you whether it was because of that drug or not, but because that person improved, they throw out the fact that who knows what happened to the other 139 people, it doesn't matter. And they can say it works. Here, you should try it because you see it works. This person improved during the time of that trial, that test. You see, if a scientist in any other field, imagine medicine, did this, he would never be allowed to publish it. Yet it is condoned by one of the top scientific journals in the world. Very proudly. And you can go there and read it yourself. that they were touting that this is such a wonderful thing and this is the best thing in the world, and, you know, and this is what happens. They find the date they want, and then they can say, see, the radiometric dating shows that we were right, because we have a sample, or maybe even a couple of samples, that were in the range we wanted them to be. And so we see we're right. But what you don't hear about is what they throw away in order to isolate down. So you remember back in the beginning we talked about how pure science supposedly is data determines theory, and then we began to question that in terms of how do you know what is data? Well, your theory determines what is data. Your theory determines what is non-data, to be thrown away, to be discussed away, or whatever it may be. And here you have an example of that. And geochronology, radiometric dating, is one of those areas that can get away with anything as long as they get the result they want. Evolutionist William Stansfield, California Polytech State, had stated, "It is obvious that radiometric techniques may not be the absolute dating methods they are claimed to be. Age estimates on a given geological stratum by different radiometric date methods are often quite different, sometimes by hundreds of millions of years. There is no absolutely reliable long-term radiological clock." Evolutionist Frederick B. Juneman candidly summarizes the situation. "The age of our globe is presently thought of as some 4.5 billion years based upon radio decay rates of uranium and thorium. Such confirmation may be short-lived, as nature is not to be discovered quite so easily. There has been in recent years the horrible realization that radio decay rates are not as constant as previously thought, nor are they immune to environmental influences. So when you have that 0.0000025%, and yes, it worked fine in this 100-year slot, so that you can say, well, that's the half-life. But the thing is that what about the other 4.5 billion years? And to realize that anytime, anywhere in there, how can you say the rates did not vary? This could mean that the atomic clocks are reset during some global disaster, and events which brought the Mesozoic to a close may not be 65 million years ago, but rather within the age and memory of man. In other words, yeah, when you have the dinosaurs in the memory of man, that quite possibly the ages that have been given to them, even by radiometric dating, are way, way, way off, because we don't know all the environmental influences that can affect the rate of decay. Radiochronologists must resort to indirect methods which involve certain basic assumptions. Not only is there no way to verify the validity of these assumptions, but inherent in these assumptions are factors that assume that the ages so derived, whether accurate or not, will always range in the millions to billions of years. In other words, you start with the assumption that it has to be. So when you have the bones of dinosaur being dated by the rock and everything else that surrounds them, you start out with saying, well, they had to have lived 65 billion years ago, therefore we'll choose the dates that fit the slot. And everything else, like the 139 other tests on that one stone, were thrown away because this is what you want. Excluding carbon-14 method, which is useful for dating samples only a few thousand years old. It is special pleading on the part of geochronologists and physicists to say that the radioactive decay rates have been carefully measured in laboratories for the past 80 or 90 years, and that no significant variation of these rates has been measured. The bottom line is really that 80-90 years of measurements are being extrapolated backwards in time to the origin of the Earth, believed by evolutionists to be 4.5 billion years ago. That is an enormous extrapolation. In any other field of scientific research, if scientists or mathematicians were to extrapolate results over that many orders of magnitude, thereby assuming continuity of results over such enormous spans of unobserved time, they would be literally laughed out of court by fellow scientists and mathematicians. Yet geochronologists are allowed to do this with impunity primarily because it gives the desired millions and billions of years that evolutionists require, and because it makes these radioactive clocks work. Okay, now we get to carbon-14 dating. All right, how do we get carbon-14? Well, you start out with nitrogen-14. You have cosmic rays enact on the nitrogen and turns it into carbon-14. And then, eventually, you have the decay of carbon-14 back to nitrogen. Now, for the ability to carbon-14 date, there has to be a certain ratio of this product, this radioactive carbon, to the normal carbon that's in the atmosphere. There's a certain ratio, and that has to be constant. If that constantly fluctuates, you see, because this way, you as a living being will absorb this ratio into your body. And therefore, when you die, that will be the basis by which to test how old you have, when you lived, how long ago you lived. And so that ratio is very, very important. It should be constant. Now, to reach that, the creation of 14, decay of 14 has to be in equilibrium. In other words, what is being formed has to equal the same as the decay to keep this constant. Now, the problem is that the equilibrium is required for the ratio of C14, C12 to be constant. It should occur in 60,000 years. So in other words, according to evolution, this should have occurred within the first birth of history. It should have happened very, very, very rapidly when you're dealing with 4.5 billion years. Okay. When equilibrium has been achieved, well, the half-life is 5730 years. So if you start at this equilibrium ratio, and now you have half of what the carbon-14 ought to be, then you know that you have passed that. And if you have a quarter of what it ought to be, then you know that twice as much has happened. And so now you've got your neat little dates that you can play with. So organism 1 dies after half-life. Only half of the C14 is in the atmosphere, of the atmosphere that started. Organism 2 dies after 2 half-lives. Only a quarter of the C14 that started in the atmosphere back then. Problem. Suppose if equilibrium has not been achieved, it's still coming. Suppose that it's growing at a certain rate, say for instance between 20 to 30%. If it's still doing that, then you got a problem, because 2 half-lives back, you may not start at that high level. You will start further down. And so say for instance you have an organism that's only at this point because only that much has built up. It's not up there yet. It's still growing. And so now this organism dies. Well, you give it a half-life. It looks like it's only been an eighth. So according to this, an eighth will end up to be how many half-lives? It would be 1, 2, 3, at least 3 half-lives. Or, if it dies at this point, a half-life later says it's at a quarter. And so, using this assumption to determine the half-life here, or to determine the actual age of when that organism existed, will throw your conclusions really far off. So it's very essential that the C14 and the C12 ratio has to be constant throughout the whole time of the animals and plants that you are testing. If it starts out lower, then you're going to have some very, very, very wonky ages being determined. Organism 2 dies, if measured immediately, appearance would be as if 2 half-lives had already passed, because it's only up to that point. After 2 half-lives, a 16th is there, appearance of 4 half-lives. Organism 1 dies after 1 half-life, a quarter of the C14 is in the atmosphere. In other words, it starts out, after a half-life, only a quarter in the atmosphere, so it has the appearance of having lived 2 half-lives ago. Now hopefully you can follow this, how essential it is that equilibrium has to be established in order for this to actually work, and work in the way it's supposed to. It is a good idea, but if you do not have equilibrium, then you will not be able to have accurate dates at all, because you will never know what was the starting proportion. Again, we have that problem. What did it start with in order to come to the conclusion that you have? Willard Libby is the originator of C14 dating. He determined after testing at every altitude and latitude that C14 was 20%, lately it's closer to 30%, greater than decay. In other words, the creation is about 20 to 30% greater than the decay. Equilibrium has not been reached. It's still coming up to the level where equilibrium, the creation, will equal decay. That would mean that the atmosphere is less than 60,000 years old. This is unacceptable to evolution. He took his data and threw it out. Just threw it out. Couldn't be right. And he established an amount that was arbitrary. He dictated what equilibrium ought to be. If the ratio of C14 to C12 was constant, the creation equal decay. However, the sun is not stable and predictable. When there are virtually no sunspots, more cosmic rays penetrate the atmosphere. C14 significantly increases. So trees absorb so much C14 that radiocarbon dating would indicate violins made from the wood were fitted together only last week. Magnetic field was once greater. Defense against cosmic rays. So in other words, these things play into how much cosmic rays can get through to affect nitrogen to turn into carbon-14. The C14 to C12 ratio has 2 quantities, also the C12 amount. In other words, how do you know that the C12 was consistently the same? Well, because decaying matter gives off CO2, which a devastated landscape cannot yet absorb. So C12 increases at a greater rate than C14. Suppose that the flood had occurred. And now you have basically things that are decomposing. And now you're going to throw way out of whack your base for your determination of the ratio. You throw out what kind of proportion the C12 has if it is rapidly increasing. Or a post-flood ice age with reduced vegetation reduces emitted carbon from less life activity or locks the carbon in extended ice masses. You know that there are some places where you have that like some lakes and other things like that act as a sump for carbon dioxide. And so how much is being taken out and how much is being put in, you don't know. Or large shallow seas after the flood might have absorbed carbon. Before the flood, a vapor canopy above the earth would reduce cosmic rays, limiting C14 production. Extremely lush and abundant plant growth on a much greater land mass above water. Everywhere that they look in terms of the oldest age indicates lush, very, very lush plant growth around the world. That would absorb carbon, take it out of the atmosphere. A greater competition over relatively fewer carbon-14 atoms. In other words, how much will be sprinkled throughout all this lush vegetation as opposed to the greater amount of carbon, or lesser amount. A greater, let's see, even half-life rates may change. We just talked about that. Fewer C14 atoms would create the impression of greater age. In other words, because these kinds of things can throw that ratio way out of whack, compared to what we think the ratio ought to be based upon our modern day, does not necessarily reflect what occurred further on back to the earliest times of the carbon-14 dating. Robert Whitelaw, professor of nuclear engineering at Virginia Polytech Institute. What if Libby's original data was accurate? Since all C14 dates were published, he postulated, well, say if you start with no C14 in the atmosphere at first, if a gradual buildup of C14 at Libby's 20%, recently 30% growth, if the dates of all once living material is adjusted accordingly to that, what would you end up with? And that's what happened. Distribution of radiocarbon dates. Now he goes up to 6,000 and probably up to 8,000 here, 7,000 rather. But you have to realize is that this is based upon the dates he's getting when he adjusts everything. And more adjustment can still be influencing so that it brings everything closer and closer to what is there in the biblical account, to the 6,000. Example of other adjustments, 40,000 radiocarbon years equals about 5,000 actual years. Contamination of the remains by growing water can lower radiocarbon age considerably, especially what's living as the flood began. The first drop-off would be sin, the sin of Adam and Eve. Another drop-off too severe to be by chance would be the flood. Worldwide Noah flood catastrophe, approximately about this time period. Men and animals in Afro-Eurasia began with a fairly large number, dropped by 60% in the next 500 years, and then built up to 350% just before the flood. A marked drop-off at the flood. In the last several thousand years, they build up to a similar peak. So in other words, what was created before the flood, created before sin, you had such lush and such variety and such, so much. And so yes, if you do drop off, it does kind of come back up again and then starts going back down again. Tree deaths begin at 624 dates, then drop off to 20% rise to 326 before the flood, then drop off to mere 35 dates. After the flood, these dates slowly build, where are never more than 25% of their post-creation value. In other words, something happened in the atmosphere for all this lush vegetation. And after the fall of man, after the flood, you still have lush vegetation, but nothing like what is indicated by the amount of dates, what the dates represent. Bury the dinosaurs. 2012 Western Pacific Geophysics meeting in Singapore. A joint American Geophysical Union and Asia-Oceania Geoscience Society event. A research team's presentation of C14 dating on many bone samples from 8 dinosaurs. Now you're looking at 65 million years old. There should be no C14 left. It should have all decayed long before 65 million years, or whatever was the ages for those particular dinosaurs. Lead presenter, Dr. Thomas Seiler, a German physicist, approached with considerable professionalism, took great pains to eliminate contamination. All gave dates ranging from 22,000 to 39,000 years, right in the creationists' predicted ballpark. Remember, they're starting at what level? Whereas if you start with the idea that maybe there was nothing and that Libby was right, these would all be adjusted down. But they're giving 22,000 to 39,000 years, but millions of years old dinosaurs should not have one atom of C14 left in them. 2 physicist co-authors, Bennett and Jean DuPont Charter, urged colleagues to do their own carbon dating of dinosaur bones, presenting the findings openly and honestly at similar conferences. This would certainly be in the interests of scientific truth, especially following the repeated findings of soft tissue of dinosaur bones, we talked about that last week, and how not even seemingly irrefutable DNA, and now even seemingly irrefutable DNA samples in dinosaur specimens. Now, what happened? Afterwards, the abstract was removed from the conference website by 2 chairmen because they could not accept the findings. They buried it. Unwilling to challenge the data openly, they erased the report from public view without a word to the authors or even to the AOG's officers until after an investigation. It won't be restored. So much for science's alleged openness to the data. In other words, okay, after investigation, they were found wrong, but it was not going to be reinstated. It was not going to be put back on them so that it's buried, because it does not match what ought to be there according to evolution's time frame. The power of the paradigm has claimed yet another victim. You consider yourself middle-aged? I can't answer that. Why not? I don't know when I'm going to die. The past meets the future, meets the past, meets the future. Fantasy worlds can be like that. See, the issue that we have talked about throughout this topic is the fact is that what is presented to you as, well, that's radioactive dating, and therefore that is infallible. Question it, because there's lots to be questioned from it. And to discover that indeed there is a lot of problems. The earth is not as old as it is being forced to look according to to the evolutionists. So the assignment, if you're going to do it, the assignments is to read chapter 6, chapter 21, which is 47 pages, of these 2 short online articles. Choose a useful focus from today's topic and in point outline form indicate how you would build the case of what you want to get across when you talk about this subject. Thank you, and we'll see you next time.